Hello, and welcome to the Amazon Web Services Partner Webinar Series. Our topic today will feature how to move your business intelligence and data warehousing to AWS. I'm your host, Sherry Sullivan. I'm with the Partner Marketing team here in Seattle, and I'd like to start with just a couple of housekeeping items. I'd like to remind folks that your lines have been muted today, but we invite you at any time to submit questions using the Q&A tool in your browser. We'd also like to let you know that we will make this presentation available on demand, and you'll receive a link post-event. And we do make our content available on the AWS YouTube channel as well as SlideShare. So I'm very pleased today to be joined by two of our AWS technology partners. We'll begin with an overview from Itamar Ankaran, who is the Vice President and Business Development and Corporate Strategy at Attunity, along with Ben Connors, who's the Worldwide Head of Alliances at Jaspersoft. Both are AWS technology partners. And we'll be joined by our own Raul Pasak, who is our Senior Product Manager with Amazon Redshift here at AWS. We'll begin with an overview of the Redshift architecture. We'll move into how to move your data into the cloud with Attunity Cloud Beam, and we'll then jump into an overview of business intelligence to apps with Jaspersoft, and we'll close with the moderated Q&A. So with that, I'd like to introduce our speakers. We have Itamar, Ben, and Raul. Take it away, Raul.
Thanks, Sherry, and thank you everybody for joining us. So today we're going to talk about moving your data warehousing and business intelligence to the cloud. And as you can see, we've got two of our partners, Attunity and Jaspersoft here, and you'll hear from them about how to move your data from on-premise to AWS and to Redshift and keep it in sync. I'm going to talk first about Redshift's architecture, how we do some of the things we do in terms of performance. And then you'll hear from Ben at Jaspersoft about how to really quickly and cost-effectively deploy BI into the cloud on top of your data. So let's dive into Redshift to start with. And just to provide some context, I wanted to talk to you a little bit about how Redshift fits into the overall picture of database services at AWS. And so what we've really tried to do is to provide a fairly complete suite of managed database services. So we have Amazon RDS, which is our relational database service. You can deploy a MySQL, SQL Server, or Oracle database with just a few clicks, and it's really designed for transactional workloads. Elasticache, which is a Memcached compatible in-memory caching service. DynamoDB, which is our NoSQL, very low latency, close to infinitely scalable, non-relational database service. And then Redshift, our newest service, which is petabyte scale data warehousing in the cloud. And with Redshift, what we set out to do was to design and build a data warehouse service that was 10 times faster than traditional row-based stores for analytic queries, at least a tenth the price of traditional data warehousing solutions, and something that was really easy to use. And the reasons for this was really that our customers asked us to build this, and that's how most of the things that we do at AWS come into being in response to customer needs. And so customers had been looking for data warehousing that was easy to provision, that didn't require hundreds of thousands of dollars or more in upfront payments, and that could match their requirements as their data volumes grew. And they also wanted something that was fast, cheap, and easy to use. And finally, something that was compatible with their existing tool sets, and that means SQL. And so what we've seen with Redshift is really an expansion in the kinds of customers that can make use of relational data warehousing. You've got traditional enterprise use cases, and for them it's been about expanding existing data warehouses or thinking about migration. And it's also about the ability to respond faster to the needs of the business. So for example, you can deploy Redshift in 15 minutes rather than having to wait weeks for purchase orders and dealing with things in terms of rack space and data centers and all of that. We've also seen a new class of companies that have been using other solutions for big data analytics start to benefit from the ability to use a relational, scalable data warehouse And here it's really about accessing business data and big data using traditional SQL and making more data available for analysis cost effectively. And then another emerging class of application we've seen is software as a service companies that are providing embedded analytics to their own customers and using Redshift to lower the cost of providing that analytics. And for them, it's really been about lowering costs, having the ability to scale, and of course, delivering performance. And Redshift, we launched in mid-Feb this year, and it's been the fastest growing service in AWS history. We've announced well over 1,000 customers, adding over 100 a week, and that was about 10 weeks after launch, so the pace of growth has been very fast. And we're focused really on making progress around security, rolling out worldwide, and continuing to innovate in line with what we're hearing from our customers. And in terms of customer use cases, just wanted to share a few with you. So Airbnb has been using Redshift, and they've seen pretty significant reductions in query times as well as cost reductions. Accordant Media is a real-time ad bidding platform, and their business is about responding to online advertising auction slots within hundreds of milliseconds. And they're using Redshift to get faster iteration on their analytic models so they can place more accurate bids. And with Nokia, it's been using Redshift to lower costs and improve query times. And again, you'll see this theme come up over and over again around performance, price, and ease of use, which is great to see. So Bitly, for example, tracks billions of clicks every month, and they've been able to use Redshift to get answers to queries that span months of data in just a few seconds. Has Offers is a mobile marketing platform that provides big brands with the ability to drive mobile applications and mobile ad performance. And for them, it's been really about performance and price relative to their current solutions for analytics. And Infor, on the SaaS side, Infor is the world's third largest ERP vendor, and they are deploying Redshift as the data warehousing engine behind an analytics platform in the cloud that they're doing for inter-enterprise analytics called SkyVault. And so the real point here is a real wide diversity of use cases, but all centered around those core benefits of performance, price, and ease of use. And from an architecture standpoint, Redshift is designed to be run as a clustered system, although we do make available a single node variant. As you can see, the nodes are connected using a 10 gigabit Ethernet non-blocking network as part of our high-performance computing environment at AWS. There's a leader node, which is your SQL endpoint that you can connect to using JDBC and ODBC and Postgres drivers. And the leader node is responsible for distributing queries across the compute nodes and then executing those in parallel. The compute nodes is where your data is actually stored. And we use local storage for performance, but we also have invested a lot of effort in automating backups and replication, so giving you all the benefits of local performance as well as the benefits of managed storage. Security is another area that we've paid a lot of attention to with Redshift, and it supports SSL for encrypting data on the wire, hardware accelerated AES 256 for encrypting data that's stored at rest, and this is every block that's written to disk, so both data at rest as well as any temporary spillovers from queries and backups, all encrypted. And it can run inside of Amazon's Virtual Private Cloud, or VPC, and that's a logically isolated section of the cloud in which you as customers can control routing, access, networking, and can connect it using VPN to your existing systems. The other element of Redshift is that it's a managed service, and so it's straightforward to provision. We do continuous monitoring of all components in the system. We automatically replicate data, and we continuously back up data to S3 as well. And so the goal is really to give you a high-performance system that's easy to deploy and operate, and also to scale. And from a hardware perspective, Redshift runs on hardware that's optimized for data processing. And so the larger node size in Redshift is the high storage instance, which is available on EC2, the 8 extra large. And this is a beefy box, 128 gigs of RAM, 16 terabytes of compressed user data. Redshift automatically compresses data when you load it and our customers typically see from 4 to 8x savings when coming from other systems. Naturally, some columns will compress much better than others, and so that also improves performance and lowers cost. And unique to Redshift, we make available a smaller node size, which is 1/8 of the 8XL, and that allows you to essentially scale up your cluster in increments that make sense for your business and data volumes. And so with Redshift, you can start with a single 2 terabyte node, which is the smaller node size, scale up all the way to 100 8 extra large nodes for 1.6 petabytes of compressed data. And from a pricing perspective, we've tried hard to make Redshift an extremely cost-effective solution. The goal here is to allow you to analyze all the data that you want to analyze, not just all the data that you can afford to analyze. And so with Redshift, you can buy it on demand. The pricing here is for a single XL node. The 8 extra large is 8 times that, but the cost per terabyte remains the same because they have 8 times as much storage. So you can see if you're paying by the hour, it costs you less than $1 an hour for a 2 terabyte data warehouse. That's about $3,700 per terabyte per year. A 1-year reservation gets you a 40% discount, and a 3-year reservation gets you over 70% discount, bringing the pricing down to under $1,000 per terabyte per year, which is well under a tenth the cost of traditional systems. And we've really designed Redshift to be the central data warehouse. Data is generated in a bunch of different places, and ultimately our goal with Redshift is to provide you with an easy-to-use central high-performance repository where you can then run analytics across all of the elements of your business. And that's why I'm really excited now to talk about and introduce Itamar from Attunity and Ben from Jaspersoft to really talk about, one, how to move data into Redshift in a very straightforward way and keep it in sync, and then how to deploy analytics on top of it. So with that, I will turn over to Itamar.
Thank you very much, Rahul, and thanks everyone for joining us today. Attunity is an Amazon Web Services technology partner, and we've been excited working with them for well over a year now on helping customers adopt the cloud and facilitate the way in which they move the data to the cloud so they can benefit from its cost efficiencies. In simply put, we help to move the data that moves our customers' business in the cloud, and we have created a cloud platform called Attunity Cloud Beam that is a data movement service that runs on top of Amazon Web Services and facilitates different processes of moving data in and across Amazon Web Services regions. When it comes to big data analytics and data warehousing, it is a core area for Attunity. We've traditionally worked for many years with many organizations, large enterprises to smaller organizations that need to make information available for analytics, and we help them move data from various environments, whether it's ERP systems, homegrown applications with the different databases, or other data repositories into the data warehouse environments. So with Attunity, we help customers to move any data at any time, anywhere, primarily for analytics, such as putting it into a data warehouse, another server for analytics. It could be RDS, for example, Amazon RDS, into Hadoop environments like EMR, or of course into data warehouses, such as Amazon Redshift. And our focus is on making the process with high performance, lower its total cost, and enable very quick time to value. When looking at loading data into Amazon Redshift, we focus on the following common use cases that we see with customers. Well, first of all is full uploads. So for customers who want to look at Redshift as an alternative to an existing data warehouse, or as a way to get into data warehousing and they want to test it out, or they may need to use it on an intermediate basis, once a quarter, once a month. So with Attunity, they can facilitate full uploads. You may need to do an initial load of the data to set it up, or you need to periodically load an entire data set for trial or ad hoc use, or you may want to migrate data, where you move a large amount of data from your existing data warehouse into Redshift. A very different use case is for customers who want to use the data warehouse on an ongoing basis and need to keep feeding it with data on an incremental, sometimes continuous basis. So basically keep it in sync with their operational data or the databases that they have on premise. They're using incremental technology, enable you to provide efficiency in loading the data, and by moving data continuously, you can enable low latency. And of course, the data may come from on-premise data centers, or it may come from another AWS region. With that said, one common issue that many customers talk about, as industry analysts report, is that moving the data into the data warehouse tends to be the most common issue. And most customers are not happy with the way that this works, are not satisfied with the way in which the loading process works. When you look at loading data, there are few reasons we want to point out. And for customers who are looking at adopting Redshift, they probably are going to be thinking about these sort of pains and issues. And with solutions such as Unity, you can alleviate them and you can avoid running into these sort of pains and quickly get your data into Redshift. First of all is the complexity, the different complexity involved in integrating different types of data sources, the different data types, how you move the data, how you move it efficiently, how you integrate different parts of the solution. So there's a lot of complexity involved potentially in moving data over a wide area network between different data centers and two different data systems. The other challenge is it can take too long. If you want to quickly get going, you want to get value quickly, using traditional technologies, special tools may take you many months. If you opt to develop a solution, it may take you many months to put it in place. With a solution out of the box, you can take that issue away. Costs can be involved with building an entire solution that can take you a lot of time. Again, if you look at traditional data warehousing, this is the area where traditional data integration tools can cost a lot, including the labor involved with putting them in place. Yet another issue is how to move data to enable low latency data warehousing, how to enable real-time views of data while the data keeps getting updated into data warehouse. That is a challenge typically to create because of the inherent complexity, and they need to do it with very minimal impact on source database systems. And finally, some of the pain points customers run into are the lack of developer resources that can put all of this in place. At Unity, brought to market a solution that we refer to as a click-to-load solution that provides a very easy way to get your data into Amazon Redshift, addressing all these issues and enabling you to take data and turn it into value inside Amazon Redshift. So with Unity, you have an optimized and affordable solution that is easy to put in place. It requires no coding and no complexity. It is an administrator environment that sets up an automated solution end-to-end. It is fast and high-performance integration, which we'll discuss in more detail, and it comes with support for incremental and real-time loading of data on top of the initial load. So it can offer you significant lower cost and faster time to value for starting to leverage and benefit from Redshift. One example of such a customer is Domain Holdings. They're a domain brokerage vendor that enables customers to monetize the use of domains. And they use Redshift for analysis, to analyze and provide data back to the customers for analysis on how they monetize information. And with Unity, as you can see in the quote here, they're able to load data within minutes and make it available in Redshift. And instead of spending months on development work and the need to have resources that can support it, they could instantly get everything done with Unity with our software as a service-based solution. So at the high level, Unity Cloud Beam for Amazon Redshift provides an optimized and automated solution end-to-end for loading data into Redshift. It supports many data sources that can run on-premise or otherwise across Amazon EC2, including Oracle, SQL Server, DB2, whether it's on Linux, Unix, Windows, iSeries, or the mainframe, Sybase, as well as other type of data sources. So we can enable you to move a lot of types of data from different databases and bring them into Amazon Redshift. A few highlights about the solution. So first of all, it offers end-to-end loading solution for Redshift, which means that we automate the full process from automatically generating a schema for the data inside Redshift to taking a snapshot of your data, which can be very large, and loading that very efficiently into Redshift, and then automatically moving into capturing changes using log-based CDC, change data capture technology, that identifies only the changes in your database and moving only the delta into Redshift. We offer click-to-load and zero-footprint architectures, which means less work to deploy and to build solutions, and we put a lot of optimizations for loading the data into Redshift. Finally, we offer monitoring and control, so you can validate and ensure that everything works as needed, and it can be alerted if anything needs to be taken care of. Our solution for loading data into Redshift provides a lot of optimizations. The whole idea is to make the process of loading data as efficient as possible. Redshift reads data the fastest from S3, and Attunity combines database integration technologies and high-speed file transfer with one optimization for loading the data into S3. So with Attunity, we have a solution that is software you install on-premise called Attunity Replicate. Attunity Replicate automatically gets data out of your database, puts it into specialized file structures that then get uploaded into S3 using Attunity Cloud Beam, and it's one acceleration technologies for moving data extremely fast and reliably and securely into S3. And then we instruct Redshift to read the data from S3 and validate that the data gets there. We follow a similar process when moving only incremental changes, or CDC, where the CDC changes get moved through a file and actually get loaded into Redshift. And once all the changes are inside Redshift, Attunity merges that data inside Redshift. So what happens with the Attunity solution is that instead of working through, say, an SQL and ODBC type of technology directly to Redshift, the data flow is highly optimized by moving the data into Redshift through high-performance data movement based on Attunity Cloud Beam, and then copy commands from S3 into Redshift, or merging the data inside Redshift. And the only communication between the on-premise and Redshift is actually an instruction channel that tells Redshift when to load the data in and validates that all the data has indeed arrived. So this sort of solution ensures high performance and high throughput for your environments. So just to highlight a few of the optimization technologies that Attunity includes is a unique proprietary transfer protocol that optimizes the delivery of data over wide area networks and the internet. That includes a lot of unique technologies. When loading data into S3, we leverage Amazon S3 multi-part transfers. We use concurrent sessions and transfers. We use compression. All the information is secure with encryption, and we support guaranteed delivery with recoverability for any issues over wide area networks. The Attunity data transfer technologies can provide you significant gains in performance, and they automatically handle different issues of variability in bandwidth, hardware, and the type of data sets that you may have. So to conclude, Attunity provides an easy way to move your data and your business intelligence to the cloud. We can make it easy for you and help you get your data into Redshift, whether you just want to try it out or want to use it on an ongoing basis. Attunity is available on the AWS Marketplace, and you can also visit us at attunitycloudbeam.com, or you can contact us at the email below. Attunity solution for Amazon Redshift is available on a subscription basis, very similar to the way Amazon provides it, which means you can use it on a monthly basis on demand, or you can commit to a year, in which case you get a significant discount. We look forward to working with you, and thank you for your time today. And with that, I'll hand this over to Ben from Jaspersoft, who will help you understand how and what you can do with the data once it gets into Redshift. Over to you, Ben.
Great. Thanks, Raul. Thanks, Itamar. And this is Ben Connors. I'm Worldwide Head of Alliances here at Jaspersoft. I'll be joined in just a few moments by my colleague Mary Flynn, our Senior Technology Evangelist, who will lead us through a demo. Just to begin briefly, what I'd like to do is show a very brief introductory video, which should launch now. So we'll take a look.
So, you're a developer or an IT professional. You want software with the simplicity and low utility pricing of the cloud. Your business users, they want apps with easy self-service reporting and analytics. And that leaves you stuck, as today's business intelligence solutions are both costly and complex to use and deploy. But what if you could get BI made easy with push-button deployment, end-user self-service, and true pay-as-you-go pricing? Now you can, with Jaspersoft's award-winning reporting and analytics platform available on Amazon's cloud. For less than $1 an hour, with no user or data limits and no additional fees, you get access to a full BI suite with self-service reporting, analytics, and dashboards. What's more, Jaspersoft for AWS automatically finds and connects to Amazon RDS and Redshift data sources, so you can literally go from purchase to analysis in under 10 minutes. And with a modern web architecture that includes an HTML5 interface, full multi-tenancy, and the ability to connect natively to both traditional and big data stores, Jaspersoft is the most trusted cloud BI platform on the market. Get rid of the cost and complexity of building reporting and analytics for your app or business with Jaspersoft BI for AWS. Check out jaspersoft.com/cloud today and see why hundreds of customers have already deployed Jaspersoft in the cloud.
So I will stop this.
So you can literally go from purchase to analysis in under 10 minutes.
Okay, that sounds like there might have been some audio problems with that video. So anyway, you probably got a little bit of the idea, and we'll get into some more details here. So the world has changed, I guess, in an interesting way. I think any of us who took classes in economics maybe learned about basis of competition in marketplaces and based on things like land, labor, and capital traditionally. But in today's information economy, that's really changed. Land and labor have become far less important. Time and information are the new factors of production. We find that knowledge workers, business users, don't have access to timely, actionable data. In fact, some studies have shown that only about 25% of knowledge workers who need data and information actually have easy access to it. Why is that? It's because most knowledge workers don't spend their time inside a business intelligence or reporting tool, and nor do they want to. Instead, we need intelligence inside. We need information to find us as knowledge workers, not the other way around. And it really has to become part of the DNA of our applications and our everyday work life. So examples are a pipeline dashboard inside a SaaS CRM application, a performance report inside a partner portal, maybe salary data visualizations inside your HR intranets, the kind of applications that you're using as part of your daily business routines, and embedding the reports, the analytics inside these applications you're already using. So that's what Jaspersoft does. We provide the intelligence inside, and it looks like we have self-service business intelligence, embeddable and affordable. What we mean by that is that we try to provide business intelligence that you can embed easily through APIs and through modern architectures like HTML5. And with that, we empower lots of people, millions of people every day, to make decisions embedded inside their applications in a very affordable and scalable way. As a company, Jaspersoft is a very high growth company, lots of momentum. We are subscription-based, very similar business model to Redshift and to Tunity, and we've been exhibiting over 50% growth every year in what we measure as annual contract value, ACV. We're the world's most widely deployed business intelligence software. We have nearly 200 people around the world. We're headquartered here in San Francisco. And as you can see here from statistics on the slide, over 300,000 community members, thousands of customers and deployments, and very broad recognition and strong partnerships. We're honored to be a member of the Amazon Web Service Partner Network, as well as you'll recognize many of the other logos here. We've been widely recognized in the press and analyst community. I'll just point briefly, one of my favorites is this sort of teal-blue center box at the top of the center column, the technology award we got from InfoWorld. This is interesting. We share that spotlight with things like Hadoop and the Apple iPad Mini. So we're very pleased to get this kind of recognition. So as far as the product goes, Jaspersoft allows you to design any report from pixel perfect type reports as shown in the upper left here to visually rich graphical representations of the data as shown in the middle, even mobile applications as you see here shown Jaspersoft running on phones and iPads, etc. So any report, any dashboard by assembling various tables and charts into meaningful views of information, as you see some examples here, and any analytic view. And in fact, we'll take a closer look at this in our demo, but here are some examples of interactive analytic views that let you slice and dice and drill into the information and assemble it in ways most meaningful and interesting to you. We can use any data type, whether it's relational from Oracle, SQL Server, DB2, Postgres, etc. Big data, including Hadoop, MongoDB, file systems, and of course what we'll be looking at today here is AWS Redshift, which is a very interesting and powerful system, as we'll see, and one very compatible with our business and technology model. We've heard a lot from Rahul and Itamar about things like time to value and performance and ease of use, and you'll see that this fits very nicely into the theme with what we try to do here at Jaspersoft. So in terms of Jaspersoft specifically on AWS, we're the first BI service you can buy purely by the hour with no user limitations, no monthly fees, and in fact purely by the hour at less than $1 an hour. Here's the actual page from our AWS Marketplace listing, and as you can see we started about 40 cents an hour for the software. Very affordable, very much pay as you go, again consistent with the AWS theme. We're the first BI service to automatically connect to your AWS data, and you heard Rahul talk about fast deployment for Redshift, a matter of 15 minutes or so versus weeks or months, and we have a similar pattern here with, we've timed it, it's actually less than 10 minutes from launching on AWS to actually visualizing your own data from RDS or Redshift, and we integrate very nicely with other aspects of AWS like security, the IAM, and this allows us to auto-discover your data sources and make it very easy to configure and deploy. We released concurrent with Redshift in February, and we have about 400 customers now, so lots of successful implementations and something we're pleased to continue. So with that, what I'd like to do is hand the controls over to Mary for a demo, and Reza, I guess Reza is going to take over first. So Reza, if you're ready, here we go.
Perfect. Thank you everyone so much. We're ready to begin by taking a look at how we can actually load our data into Redshift. And as mentioned by Itamar earlier in the demo or in the presentation, Untitled Replicate is the piece of software that would be used in order to load data into Redshift. So what you're looking at right now is the Untitled Replicate console. In order to save time with the demo, I've gone ahead and predefined a couple of things here, including my source and target. We're going to be loading data from an Oracle data source. So I'll do just a quick test here. As you can see, it's a very basic definition in terms of how you connect to your source. The Oracle, you just need the connection string as well as the username and password. And then for Redshift, there are three pieces of information that's needed. You need, of course, the Redshift cluster information, what database name you're going to load the data to. You need an Untitled Cloud Beam subscription, which is something that you set up by going to untiledcloudbeam.com. And then, of course, you need an Amazon Staging S3 bucket that's in the same region as the Amazon Redshift cluster that you're loading the data to. So I'm just going to test my source and target here to make sure that everything's okay. And with that, I can move straight into creating my new task. So I'll call this Oracle to Redshift. And as you can see, I've selected by default to do both full load and apply changes, meaning we also can do the change data capture as part of this task. So with that, I'll click OK, and this then allows me to drag my Oracle source and my Redshift target into the interface. And at this point, we're ready to start doing our table selection. I can load up the schema from the source database, search and include specific tables that I want, or we can use include and exclude strings to select tables based on specific patterns. But in this case, I'm going to select a few tables explicitly. I'll add that to my list of tables, hit OK, and then I'm ready to start loading data already. However, if I wanted to do some customization or transformation, I have two options. I can do a global transformation, or I can go to an individual table and set up a transformation that would make sense for the data, for loading the data into Redshift. So I can go to my transformation here and select any number of different types of transformations I want, including the ability to add new columns or do calculations on existing types of columns that are already there to load the data and make these transformations in real time before loading the data into Redshift. So I'm pretty happy with these selections right now. I'm just going to load all the data as it is from the source. I can save my task and hit the run button, and that's it. That's all that's needed in order to actually load your data into Redshift using Trinity Replicate. And as you can see, when I run this task, there are a few things that will happen. First, we will prepare the target tables by creating the target schema based on how the source is defined, or we can use an existing schema that you would specify in the task settings. And then we will load the data from the source into the target and then keep the target tables up to date by performing CDC updates from the source to the target. So I'll click OK, and this will start up my task. If I connect using SQL Workbench to my Redshift target, we can take a look there and see that in the natality database where I'm loading this data, if I refresh that, right now the HR database has not yet been created. We're using actually the HR schema to load the data. So all of the data now has been queued up for loading. And once it moves over to loading, you can see the estimated count of all of the data being that's going to be loaded as part of this process. You can take a look at the throughput to give you an idea of how long it will take to load the data in terms of the number of rows that are being handled per second. And once we're at the loading stage, if we go back to the target and refresh this, we can then see that the HR schema has been created, and those 4 tables are now available in Redshift. As we continue to monitor things here, you can see in real time the data as it gets loaded, and you can monitor this to understand the throughput that you're getting as this click-to-load process is happening. And that's it. It's completed. All the data is now updated and is ready for use. But of course, as you want to move forward with this and you want to ensure that you're keeping your target data in sync, we have the change data processing or the change data capture process that allows you to monitor the source and continue to load that data in real time. So what I have is a little application that allows me to insert some data into my source. So I can insert 1,000 new rows and then update those rows very quickly on the source. And as you can see here, I'm auto-committing these changes to the source. So automatically, if we take a look at the change processing mode, we now have 2,000 rows being updated here in 2 transactions. And we can take a look at the apply latency. This allows me to monitor and see exactly how long it will take to apply these changes from the source to the target. Once the throughput or the applied throughput actually begins, you would be able to see as well this being updated to show you that those changes have actually been applied and these updates have been made into the Redshift target as well. So with that, it's a very, very easy process to easily use the Trinity Replicate to click and load your data into Replicate, into Amazon Redshift. At this point, I want to transition over to Mary Flynn from Jaspersoft, who would continue forward with the demo.
Thank you, Riza. All right, folks. So what we're going to do now is we're going to take a look at Jaspersoft in action. So let me make sure that there we go. Okay, so we've got on the screen Jasper Report Server. If you look at the URL across the top, it's running on EC2. So you've got Amazon AWS going on there. And the significant part of it, what makes this so easy, is that we are automatically going to detect that Redshift instance. So Jasper Report Server is running in the same AWS environment as Redshift. So this is my console right here. My server is actually locatable through the EC2 over here. And I'm just going to show you Redshift real quick. And this is what Riza had just uploaded to. He uploaded to this environment right here. So Riza, I forget where you're located. I know that Ben's in San Francisco. I'm on the East Coast. We're all over the place, and we're all using the cloud. So this is what we're going to connect to. So let me log in as the super user. Oops. I changed my password. Log back in. There we go. And what I'm going to do is I'm going to show you how to make that connection real quick, and then we're going to do some quick analysis, and we'll wrap up with some Q&A. All right, so what I want to do is I want to show you that data source that Riza had just uploaded to Redshift. And you'll notice here that the type for the data source is automatically set to AWS, and it detects that based on the URL up here. Now, I could also choose other types, so for example, your traditional JDBC and so on, but AWS is automatically detected. And I'm going to give this just a name right there, so it's uploaded by a TuneID Cloud Beam. And this is the really cool part. Let me just put a location here, otherwise it's going to give me an error. Down here, all I need to do is just click on Redshift, and it automatically detects this. And this is what makes it so easy and so powerful to get started with this shared solution. Now, if I were trying to connect to, let's say, some sort of hybrid environment, I could use alternative ways to get in, but this is the default and automatically picks up. It knows based on my login credentials what group I belong to, and it automatically detects the Redshift. And alternatively, it could also detect the RDS instances. All right, so what I'm going to do now is I'm going to log in just like Riza had done in his environment. And you'll notice that it automatically creates the URL for me. I'll do a test connection. Try that again. Okay, there we go. So I just had a little typo. Okay, so the connection passed, and now I'm going to click Save. So my data source is now set up. So this is all great and wonderful. What I'm going to do now is I'm going to create a domain so you can see how quickly you can get. And earlier in the slide presentation and the animation, it said you can get from 0 to 60 and very quickly. And this really is the case. So let me show you what I mean by that. And I'm just going to do this very quickly. And this is the one that I had just created. We won't go from beginning to end on this. It's sort of like a cooking show. I already have something already set up that I'll bring up. But this is the schema that Riza had created on the fly using CloudBeam. So I'm going to click OK. Those are the tables that he had uploaded. I'm going to bring 3 of those in. And I'm going to do a quick join on those. So I'm going to bring up employees, and I will link those. So on department, I can link those and inner join on department ID. And for jobs, I can do an inner join on job ID. And then I can go in and I can create the metadata model. So I can bring all these items in here. I can choose to have things in different order and have different ways of describing it and all sorts of good things. So just assume that I had gone through this process of, for example, let's say removing the ID and changing the department name so it's a little bit more user-friendly. And click Save. Okay, and then I can go through that whole process, and then I can, as an end user, I would be able to take this and create my own reports. So let me show you what that looks like in real life. So I'm going to create, let me just log out, and I'll log in as a regular user. Okay, so I'm no longer an administrator. Okay, sorry about that. I guess I will just go in as my regular guy again. My apologies. Okay, so I'm going to create an ad hoc view. And the first thing I will do is take that view based on the data that, that Riza had uploaded. So I'll go in here, and this is the one I had created ahead of time. And I'll choose the data, and I'll bring in all the employees. That's my metadata view. And then I can go into the crosstab view or create a chart or whatever it is. And you'll notice here that I've got things a little bit easier to understand. So I can bring in, say, employee ID, first name, last name. And you can even set up certain fields to be restricted. So depending on who you log in as, some people may see different fields than others. Or people may see different rows. So if you are allowed to see salary information, you might see that for only your direct reports, but not for others. So all that can be worked into the Jaspersoft environment. Okay, so that's just to show you the beginning to end that you can actually get the data from whatever your source is. As Riza has shown, use Cloud Beam, bring it up, put it into Redshift. It's all ready for processing. Jasper Report Server goes on top of that. Now let's show you some of the power of Redshift, because Redshift can be very fast and very cool. Now what I'm going to do is I'm going to use a much larger data set. What we're going to do is we are going to use birth records for the United States for the last 4 years. So I'm going to bring that data in, and this was modeled again using the Jasper Reports server domain. And then here you see the different fields that are available. This is loaded into Redshift, and we're going to create a quick chart out of it. Okay, so the first thing I want to do is bring in the total count of babies. So I'm going to say bring in baby count, and I'm going to drag that into the rows. Okay, now what just happened there when you saw that little dial going around, it was going to Redshift and creating a query, and you can see how quickly the information came back. And remember, this is all happening over the cloud. So the total number of babies born over the last 4 years is about 152 million. Now, if I want to, let's say, analyze that, maybe break it out by father's age, see if there's been a change in age or what the average father age is, I can drag that into the report as well. Let me just bring that in. Goodness gracious. Give me 1 second. Try that again. Okay, so we'll bring in the natality data, and we'll bring in the baby count. Okay, and now we're going to break this out by father's age. There we go. Okay, so it's going back to Redshift. And what I want to do is I want to expose the total number of ages. So I've got this little slider over here. So I'm going to drag that down. It's just basically a drilling down. And you see there's this big spike over here that's throwing everything off. And that is basically 99 is essentially the placeholder that hospitals enter in when they don't know the name. So what I'm going to do is I'm going to apply a filter, exclude that. So all I have to do is select a field here, say create the filter. And I'm not so worried about the tail end of either side. So I'm just going to arbitrarily put 65 in there for the upper limit. And again, it's going back to Redshift. So it's pushing the hard work down to the database in this case. And there's a lot of records there. So Redshift is coming back pretty well here. And I can see that the average age over the whole 40 years is about 28. Close next to that would be about 27. Now let's see if we want to figure that out broken out by year. In particular, let's do it by decade. So what I'm going to do is I'm going to create another filter. This time it's going to be by year. And I'm going to choose a couple of decades of information, or just the decade turning points. So it's populating the list here, again going back to Redshift. And we're going to pick up 1970, 1980, and 1990. And then we're going to see whether the baby count and whether the father's age has changed over time. Just give us 1 second. Usually it's very, very fast. Seems like there's a little bit of a hiccup. Okay, while we let that happen, what I want to do is to show you in the background here that if you wanted to find out how quickly you can get up and running with Jaspersoft and AWS, you can go to jaspersoft.com/cloud, and you can also go to our community site. So you can go to community.jaspersoft.com, and you'll find a page here on AWS. And in here, there are some nice videos to get you started, how to actually get launched, get started, how to connect to your database, whether it's going to be Redshift or RDS or anything else, and then a variety of other information on pricing, et cetera. So let's see if this came back. Okay, great. Okay, so I've got 1970, and I'm going to choose 1980 and 1990. All right, so with those 3 years selected, I can see that the average age is 27, but if I want to break that out by those years, I can drag that into the report as well. So I'm going to take year and drag it into rows. And now we're going to see that bell curve that's going to be distributed amongst those 3 years. Just do a little slide down here. And now I can see 70, 80, and 90. This isn't the easiest way to interpret the information. It might be somewhat helpful for smaller sets, but let's do something different. Let's change this to a different type of chart. Let's change this to a spline chart. Okay, and keep in mind that I'm doing all of this over the web. This isn't that interesting, but if I switch or pivot these groups here, you're going to find that we're going to have this nice little bell curve, and it's going to be breaking things out, and we're going to be able to see the distribution much more clearly. Okay, so here we have the total number of babies goes down for each decade, but also, so that's the height up here, but also the shift changes. So in 1970, the most common age was 23, and then after that was 27. And then there seems to be a pretty fair distribution in 1980 between 25 and 27. But you see, as time goes on, the average age of fathers goes up. So here we're looking at 29 in 1990. Now, there are a number of things that we can do. In the interest of time, I don't want to take too much of it. I'm sorry for the little glitches we have. But just so you know, you can save this out. So once the view is saved in the Jaspersoft repository, you can share it with other coworkers. You can open it up, make other changes. You can do zooming. You can have things scheduled to go out on a periodic basis to your peers and so on. And one thing I do want to show you is this view SQL. Each time I was requesting something from Redshift, Jasper Report Server was creating the SQL statement, and you can see right here what actually is going back and forth between Jasper Report Server and Redshift running on the cloud. So I wanted to show you a little bit more, but in the interest of time, I will hand it back over to Sherry, and my apologies for that little hiccup earlier.